So let's look at how we can use substitution to solve our linear system. So sometimes you might see a system where you already have a variable that has been isolated. In other words, you know what the variable equals. In this instance, we have a slope-intercept form equation and y equals 3x plus 2. Since we know that y equals 3x plus 2, we're going to simply substitute this expression, 3x plus 2, into our variable for y in the other equation. So we're going to rewrite the other equation since this variable is already solved for. We're going to put x plus 2 times y equals 3x plus 2. And you're always going to want to write your expression in parentheses, okay? And then don't forget to finish writing this out. So this was x plus 2y, y equals 3x plus 2, and that whole side equals 11. Then we're just going to distribute and finish solving. Notice that we only have one variable left to solve for, which means we're going to get the exact value for what that variable equals. And in this case, it's x. So we're going to have x plus 2 times 3x is 6x. And 2 times 2 is positive 4. All of that equals 11. Look to see if you can combine any like terms. And you can. You have x plus 6x. That gives you 7x. Plus 4 equals 11. Now we're going to subtract 4 from both sides. And we get 7x equals 7. Last step is to divide both sides by 7. And we see that x equals 1. So we have done step 1, except for one of the equations was already solved for x or y, and in this case it was solved for y. If this is done, we went to step 2. Substitute this expression for x or y into the other equation. We did that here. Solve the resulting equation for the remaining variable. We've done that. Now we're going to do step 4. Substitute the known value into either of the original equations to find the value of the second variable. What that's saying is we started with these two equations, right? We had these two as the system. Now that we know the value of x, and remember we're solving for the x and y in both that make them both true. So it doesn't matter which one we pick. You can choose either one. You can take the one and plug it back into this one here, or plug it into the first one. I'm just going to use the first one. So now we're trying to find the y value. We have x, now we need y. Well, y equals 3 times x, and we know what x is. It's 1. So 3 times 1, and then plus 2. Well, that tells us that y equals 5. 3 times 1 is 3, plus 2 is 5. So we now know the x and y value that are going to make both of these equations true. In other words, it's going to make both of it's going to make the system true. Our ordered pair then is 1 for x and 5 for y. So if we were to graph this, the point 1 for x and 5 for y would be the intersection point of both graphs. Step 5 is always to check your solution in both of the original equations. So at this point, when we check, we're simply just rewriting these and plugging in the values we have solved for. So in the first one, we get 5 equals 3 times 1 plus 2. That is correct. In the second one, we have 1 plus 2 times y, which is 5, equals 11. And 1 plus 10, 2 times 5 is 10, equals 11. And these are both correct. So the correct solution to this system is x equals 1, y equals 5. The only thing that's going to be different in the next few practice problems is that you may not already have a variable solved for. So they both might be in standard form. And in that case, you're just going to solve for one of the variables, either x or y, and then substitute in that value. Make sure you're following these steps. I would take the time to write these steps down in your math notebook, along with the example that I've done here for you. So I want to give you guys some time now to do some practice problems. And if anything comes up as you're working where you get confused or you're not sure, you can rewatch this video and go through the steps to make sense of it. If you're still confused, make sure you write those problems down and we will go over it in class. Okay, happy learning.